Polynomials. All right, what is a polynomial? A simple number like 3 can be a polynomial. 4x, that's a polynomial. I'm going to give you a bunch of examples of what polynomials are like, and then we're going to classify them. These are all examples of polynomials. All right, so let's classify all these polynomials. This is a constant because that 3 is never going to change. And this is a constant. And we call this a monomial. Mono meaning 1, because there's just one term, which is the 3. Okay? 4x, that is also a monomial, and it is of degree 1, because we look for the degree on the exponent on the variable. And the exponent here is 1. So we say that this is a linear, because we know that if it has exponent of 1, it's linear. And it is a linear monomial. And that's classifying it. Let's classify this third one. And we know this is quadratic. We have 2 terms, so we call this a quadratic binomial. Classify the polynomial. That's how you classify those. Okay. The fourth one down here, 5x cubed, is a cubic. Because we have 3 terms, it is a cubic trinomial. Cubic trinomial. Right. The 6x to the 4th plus 3x cubed, because it's of degree 4, we call this quartic. Q-U-A-R-T-I-C. That is a quartic. And it's more than 3 terms, so we're simply going to say this is a quartic polynomial. If it's any more than 3 terms, it's simply a polynomial. Okay. All right. Negative 4x to the 5th minus 2. We have something to the 5th power. It is quintic. This is a quintic polynomial. And specifically, because it only has 2 terms, it is a quintic binomial. Right? And so that's how we classify these polynomials. They are all polynomials. All of these are polynomials. If it has 1 term, it is a monomial. 2 terms, binomial. 3 terms, trinomial. More than 3 terms, polynomial. We have a constant, linear, quadratic, cubic, quartic, quintic. Yes, Emma.
I'm confused on what you mean by terms.
Terms, good question. A term, terms are separated by pluses and minuses, adding and subtracting. So we're not adding, subtracting one term. We're not adding or subtracting anything. It's simply 4x. Okay, so that's monomial one term. In this third example, 2x squared plus 5, that's two terms. 1, 2. So it's binomial. In this term, 5x cubed minus 2x plus 1, we have three terms. We have 5x cubed, we have negative 2x, and we have 1. Three terms, trinomial. Okay? Yes?
How come, like, for example, the quartic polynomial, it has, like, the x, the power 4, but there's also next to it.
Right. We don't add the exponents together. We take the highest one.
Oh.
All right. Yes, it's the highest one. All right. And the last one, 7x to the 6th power. But when we want to classify that, we have more than 3 terms, so that's a polynomial. We have 1, 2, 3, we have 4 terms. It's a polynomial. We can just say it's degree 6. There's no fancy name for that. So we can just say this is of degree 6. It's a degree 6 polynomial. But everything from linear to something to the 5th power, there's names that we call those. Linear, quadratic, cubic, quartic, and quintic. Monomial, 1 term, binomial, 2 terms, trinomial, 3 terms. Anything more than 3 terms, it is simply a polynomial. Okay? And those are all examples of polynomials. Any questions on that? Now, do you see anything like that up there? No, because that's not a polynomial. And we don't see anything where absolute value, because that's not a polynomial. We don't see anything where we have variables in the denominator, because this is not a polynomial. Okay? Polynomials, they have to have a variable not in the denominator, and the exponents have to be greater than or equal to 0 in order for this to be a polynomial. So these are examples over on the right side here. These are examples of what is not a polynomial. Okay? All right. So let's say we have a polynomial that might look like this. Right? There's a polynomial, degree 5, so that's a quintic polynomial. Evaluate this polynomial for x equals negative 3. Okay? And you guys all have calculators. So if you would just take a second and evaluate that for me when x is equal to negative 3. There's a few problems I will show you that you'll have to do in homework. Somebody got an answer? As soon as somebody gets an answer, just holler it out.
Joint fraction or decimal?
Decimal's okay.
128.275.
128.275. Did anybody else get that? You did? Okay. What did you get?
I got 192.475.
I got 198.475. All right, and I will show you on the screen, because a lot of people got this answer, 198.475. I'm going to assume that it's right. And hopefully you guys have used parentheses when you insert a negative answer, a negative value for x. All right. So those people on the website won't be able to see the solution on the TV, but that's the best we can do.
You can write it up there.
I guess I could. Minus 5/8. So you can see the way you have to add that into your calculator, making sure you use parentheses when you insert a negative number. Okay? All right. Next example I want to give you guys. We're going to be taking these polynomials and adding and subtracting. Basically what we're doing is we're just combining like terms. So, by the way, did you notice how I'm writing all these polynomials with the highest exponent first and then going down in descending order? Did you notice that? That is a standard form. Would anybody have any trouble adding those two polynomials together? Okay, because basically what we're doing is we are adding like terms. All right, and I'm going to change one of these values. Let's make this 20x squared. Let's turn that into 20x cubed. Okay, now what I'd like somebody to do, I don't think we're going to have too much of a trouble adding those. Subtracting might be a little bit tougher. Okay, would anybody like to volunteer to come up and do this on the smartboard? All right. Kirk Nicholson, it's all yours. And then when you're finished, I want you to classify that polynomial for me. Yeah, put the wristband in. notice he's putting everything into standard form. Okay? And this is a what? Classify that.
It's a degree 6 polynomial.
Degree 5.
Oh, degree
So that'd
5.
be quintic.
So quintic polynomial.
Quintic polynomial, correct. Okay? Now, I'd like somebody up to come up and in the red marker do the corrections. Who would like to do that?
Wait, like I have to show like what you do.
No, just make the corrections. You can have the eraser and the. Okay, how? You had your hand up first. Hunter.
So this would be, can I just write over it, or do you want me to?
You can use the eraser if you want.
So this would be plus 10x squared, or x
Okay.
to the fourth.
I
And
believe
then
you're right.
this would be minus 23 x to the third.
Okay.
And then this would be plus 10.
All right. Thank you. And would anybody like to make a correction on that one? Read.
8x on to the fourth, isn't it? 8x.
Yeah. 2x to the fourth.
2x minus 8.
And that would be 8x to the fourth.
Oh, sorry.
That's okay. No, and I'm, you know what? I'm glad we made mistakes because that typically is what happens. And so this becomes 8x to the fourth, okay? So it is easy to make those mistakes. So what you may want to do is you may want to write the second step as you're solving these problems. It may be easier to do this. And then distribute the negative. So it may be better, especially if you're getting a lot of these wrong, to distribute the negative through the second parenthesis, and then go ahead and combine like terms. Okay? And as you're doing that, it is also helpful, 2x to the fifth minus 5x to the fifth gives you negative 3x to the fifth. So it is helpful to strike them out too as you go, so you don't get confused, especially when you have a long string of terms. Okay? All right, so our homework for tonight is on page 429 to 430, 12 through 58 even, and 59 to 63 all.